This will be the first of 4 examples that I'll go through and that you need to know how to do in preparation for the exam. If you know how to do these 4 problems we're going to go through and you understand exactly what's going on or near to exactly what's going on, you should be just fine. So let's take it from the top and start with the a distribution, and more specifically the distribution relative to a descriptives. And what's happening here is you have a company called Stickley Furniture, and if you're not familiar with Stickley, they're a high-end manufacturer of furniture located up in their headquarters in Syracuse, and they have offices pretty much in the Northeast. And what they're attempting to do here is they're attempting to understand the relationship between the number of radio ads aired and sales on any given weekend. And here's the raw data. So for example, you have the radio ads in Providence, and they created those ads created 15,000 sales. Here's New Haven, five ads created 21,000 sales, and on and on. There's actually 6 cities that this data has been provided on. And so what you need to do is you've been handed this data set. You're the operations manager, or you're the manager of the stores that are the vice president of operation for all these stores. And in fact, I actually know the fella. His name is Mike Noblot, and a smart guy. And here's how he would potentially, or a business person in general, would analyze this situation. So you're handed this data set, and what's the first thing you do? You take a look at the variables, and the variables here are radio ads, sales, and then the locations. Now, you have this data, and you want to understand what exactly is the data set telling you, or begin understanding the data set. And as with any data set that you're presented with as a business person, the first thing you'll do is you'll start running the mean mode, median, range, and then standard deviation. In this case, the standard deviation has already been pre-calculated by somebody who works for Mike, or would work for you potentially as well. And the standard deviation is 5.5. And what we're going to start out doing is what are the mean, the mode, median, range, and then I want to label those on a distribution curve. And you will actually have to do this on the exam. And then what we'll do down here is we'll start talking a little bit more about the relationship between the variables, and then eventually we will go down here and create some type of business recommendation that would be applicable to the findings. So let's take this from the top. The first thing to do is determine the mean. The mean is just simply taking all of, and we're going to do this for sales. Okay, we're going to do this for sales. And so all you do is you add up these 6 numbers, and if you added those up and used a calculator, you'd be 102. By the way, you won't need a calculator. They'll be much easier. Well, these are pretty easy numbers, but they'll be easier numbers on the exam. So you won't need a calculator, and if you need any help during the exam, I'll be your human calculator. And just raise your hand. And so the mean is 102, and how many cities are there? It's divided by 6, and if you work that out, you would get at the mean. And this is the mean of is a population. Okay? The mean is equal to 17. Now you also know that the mode and the median are 17 because of a couple different ways. One is, let's go first at the median. And the median, all you do there is you order these in either ascending or descending order, and you go 8, 15, 17, 17, let me see, 21, there we go, and 24. And then you look at that and you go, okay, what is the number that's right in the middle? And obviously, if you go 1, 2, 3 down, this is 6 points, and it's going to be 17, because since these are 2 numbers, that's an even number of data points. What you would do is you would divide 17 by 17, you get 17. Now if this were 16 as an example, you'd take 17 and 16 and divide by 2, and you'd get something slightly lower at about a 16.5. But in this case, the mode, or let's call it the median. Median is what we're doing here, is 17. Now the mode is really pretty simple. You got 17, 17, 24, the number 24, 18, 5, 15, and the number that happens the most often, or occurs most often, is 17. So that's pretty much what you'll see on the exam. You'll be given data points, and now what you'll need to do from there is you'll have to sketch a distribution curve showing these different data points. So let's do that. What you have here is you just draw a line across, right? And then I don't take off for artistic ability or lack thereof. So you come in here and you draw your curve, and you know that the mu, the mean, is 17. You know that the standard deviation is 5.5. So you just come out here and you go 1 plus 1 standard deviation and minus 1 standard deviation. Again, I don't take off for artistic ability or lack thereof. And so 17 plus 5.5 is 22.5, and 17 minus 5.5 would be 11.5. And so this would be your mu, and this is your plus or minus 1 standard deviation. Now the interesting thing here is, you know that as you've calculated or determined before, looked at before, that in between plus or minus 1 standard deviation, you're looking at 68%. So what that means is if you put all the numbers, these 6 numbers, or really any other numbers that are going to occur as part of a future study potentially, since this could be a sample of future study, is you put these 6 numbers, I'm going to keep using 6 in there, and you put your hand in the pot and you pull it out, and the probability that you're going to get between 11.5 and 22.5 is 68%. Now, that being said, let's go back to the actual problem itself, because what we want to do is we've got this set up. We've got the mean, we've got the mean, we've got the plus or minus 1 standard deviation, and you would label this 1 plus 1 SD and minus 1 S or D, because it's a well, let's actually call this a sigma, because like I said, this is the population. So let's go plus or minus 1 sigma. There we go. That makes it even easier, because we assumed this was a population as opposed to a sample. So that's how you would sketch, and then let me see. I don't think there's anything else there. Mean, mode, and also, it's kind of an interesting situation, is you've got, or what will be a normal situation, is that your mode is equal to 17, and your median is equal to 17, right? That's what we determined. Pretty straightforward. Now, one of the kind of dispersion calculations we didn't do just yet was the range for sales, and this wouldn't go on the distribution chart, but the range would, you just simply take the highest number minus the lowest number. The highest number here is 24. The lowest number is 8. So 24 minus 8 is 16. And then what you'll be given multiple choices as far as making sure that you understand, or you can pick out the proper numbers from a list of 4 or 5 choices, A, B, C, or D. So that's that part. Let's take one more specific to descriptives, as the book defines descriptives, which is mean, mode, median, range, standard deviation. And so now we take this and we say, okay, would we anticipate positive or negative skew? And if you'll recall, the mean, the mode, the median are all the same. So you would expect in this case, is a little bit of a not a trick question, but making sure that you understand that when you see these 3 numbers are the same, you have 0 skewing. Okay. Now, if this number were 18, right, you would have a negative skewing, because once you put that basically says you have more numbers on this side, so you get some negative skewing, and that would pull that tail a little bit more on the negative side. That's how I remember it. The other side is if, let's say, for example, if the mean or mode was 16. Now you'd have positive skewing because it would pull this tail just a little bit longer than it was before. You'll have multiple choice, and I would highly encourage you to show as much work as you can. Or if you want to get partial credit, you need to show as much work as you can, or unless you're asked to show the work. So we already decided that it would be neither negative nor positive skew. So then we go on down in here to the additionally, which is the dependent variable. And so the question here is, you have radio ads and sales. One of those is an independent variable, and one of those is a dependent variable, or an outcome variable. And so you need to ask yourself the question, do sales drive radio ads, or do radio ads create more sales, or drive sales? And obviously, radio ads would drive sales, and it really doesn't work the other way around as far as sales driving radio ads. So the dependent variable here, the DV, would be the outcome, which would be sales. And obviously, the independent variable, which is the predictor or antecedent, goes by a number of different nomenclatures, is the radio ads. And now what we want to do is we want to draw a scatter diagram for the 6 radio ads and results by city. And what we're going to do with that is we're going to start trying to understand what is the relationship. Is it a positive relationship, a negative relationship between radio ads and sales? And what would you expect? Would you expect that radio ads would as you increase radio ads, sales would go up? Or would you expect if you put more radio ads on, sales would go down? Normally, you would expect if you put more radio ads on, sales would go up. What if you put more radio ads on and sales went down? Well, that business decision would be really easy there. Is that assuming there was no huge snowstorm in the southeast when these or in the northeast while the radio ads are being published or not shipped out but heard by potential customers, you would say, well, that probably isn't the best ad in the world. In fact, our sales went down, so that definitely is not a good advertising program. So the scatter diagram is pretty simple, and you don't even really need. I'm gonna not do this with lines, because you can see where it's really pretty easy to create this X and Y scatter plot. And so you have X, you have Y. And as we said, the Y is going to be the outcome, which is sales. And the X is going to be the independent variable, which is going to be radio ads. And then you come in here and you say, oh, radio ads, they range from 0 to 6. You come in here and you decrement 1, 2, 3, 4, 5, and 6. All right. So, and over here on sales, it ranges from 8 up to about 24. So you'd go 5, 10, 15, 20, and 25. So how do you sketch that? You've done this before. You did this on one of the previous exercises, or at least a couple of different exercises, I'm sure. If you didn't do it in class or in Wiki or as part of the chapter or module 3 quiz, all you do is you come out here and you say, okay, provenance, 4 and 15. So you go 1, 2, 3, 4, and then 15. And that is a data point. All right. Now you're going to have 5 others. You're going to have 2. And then 8, and here's 5, and here's 10. So you put it kind of right in here. Again, this exercise at this point is not an accuracy sort of exercise. What we're trying to do is understand this relationship between radio ads and subsequent sales. So then you come down here and you go 5, 1, 2, 3, 4, 5, and you go up to 21. Clearly getting a pattern at this point. It looks like it's going positive. It's going to be a positive relationship, which as we expected. So let's put a couple more in here, 6 and 24, and 3 and 17. And then the last one is 5 and 17, 2, 3, 4, 5, and 17. So if you draw, just sketched a best fitting line, you see that that is a positive relationship. So as you increase radio ads, sales will increase as well, at least for this specific ad campaign. All right, so you're going to get, it's going to be a positive. If we're going this way, okay, that would be a negative slope. But with ads and sales, that's probably not going to be the case, you would hope. And then the final three questions are, if R were 0.7, how would you describe the correlative relationship between radio ads and sales? And as you hopefully recall, again, I don't take off in artistic or not being able to draw straight lines, is that your correlation value R, can range from +1 to -1.0. And so here, if you had a +1, that would be the strongest relationship, the strongest positive relationship. And if you went this way, a 1.0 would be the strongest negative relationship, meaning that the slope would go down. Now, if you, as you've seen before, as you worked on before, is that if you had and it kind of ranges, and there's a lot of different ways to interpret these numbers, but about a 0.7, that's fairly strong. That's a fairly strong relationship. So you would conclude here, if you end up having a 0.7, that you would have a relatively strong, or perhaps even a very strong relationship between radio ads and sales. Now, if you came in here and it was the R value that is calculated, the correlation factor, the linkage between these two numbers, if it ended up being 0, what would the relationship, how could you describe the relationship? Be pretty easy. It would be there is no relationship. And that just means you have randomness and there is no pattern or slope, either positive nor negative. Now, let's say it came in at -1. It came in at -0.1 on a scale from 0 to 1.0. That would be a pretty weak relationship, is the way you'd describe that. You might describe it as a fairly weak relationship. And here again, you'll get some choices as to whether or not the relationships are strong, weak, very strong, and then you'll have to decide whether it's a positive or negative slope. And keep in mind that if you've, as we've talked before, this is a positive slope, and this is actually fairly strong. This is probably about a 0.5, so it wouldn't be quite as strong as a 0.7. So this one would probably be somewhat strong, as far as if it were a 0.5. Oh, and here is the 0. If the relationship is 0, there is no slope. That's what that curve, or not curve, but that line would look like. So now the next question is, the final question is, so what? We've created all these values. We found out what the average was, or the mean. It says 17. The mode is 17. We've got a normalcy of distribution, which is a really good thing, because then we can because if you didn't have normalcy of distribution, you would not be able to run a correlation analysis. You'd have to use some other testing technique that was more, again, this are kind of getting into future type of courseworks, but parametric versus non-parametric. So once you get to normalcy, you can begin running these correlation, and later in probably the next module or two, we'll start talking about comparison of the means and t-tests. So you've got, everything looks good. You've got normalcy of distribution. Your correlation analysis is valid. You're not on a sample, so you're actually looking at the entire population. And so now what would your decision be? Or what would one of the a potential decision be? More specifically, would you keep running these ads? Would you increase the ads? Would you keep them about the same? Or would you run the ads in perhaps another market, if you want to think outside the box a little bit, run in another market and see, okay, what happens when I go outside of, these are clearly up in the very northeast. What if I had a store in Pittsburgh or someplace like that, and it's a little more Midwestern? And let's see if you want to see if these numbers hold up. So those are some of the business decisions, and that's more or less concludes this specific example that if you know what's going on inside of here, you will do fine on the exam. It's going to be multiple choice. You won't need a calculator. I probably didn't need a calculator here, right? And so you would just write out. This will probably be a short essay where you'd write out a couple, 2-3 sentences as to what your business recommendation would be. And that concludes the first category that'll be covered on the exam, which is descriptives, and I also include correlation inside descriptives. By the way, that's a little bit of a Schulteism.